evening on August 4th here in New Zealand at Rocket Lab's Mission Control Centre as we count down to the 5 p.m. local time launch of this national security mission for the National Reconnaissance Office. On your screen is a view of our Electron rocket vertical and ready on the pad at Rocket Lab Launch Complex 1 in Mahia on the East Coast. My name is Muriel Baker. Thank you for joining us for our 29th Electron launch to deploy the NROL-199 payload to orbit. Our first attempt at launching this Antipodean Adventure for the NRO was stood down earlier this week due to strong winds, but with much more settled weather today through the launch countdown so far, we are on track for launch right at the top of the launch window, opening at 5 p.m. local time. That's 5 a.m. UTC and 1 a.m. Eastern Daylight Time, or 10 p.m. Pacific if you are joining us from that time zone. Today's NROL-199 mission is the NRO's fourth launch of the year and the second on Electron from Launch Complex 1. It's one of more than a half dozen launches planned by the NRO in 2022 to help provide 500,000 plus government users with intelligence information that enables them to protect the United States interests and support worldwide humanitarian efforts. Now at T-minus 12 minutes and 41 seconds and counting, shortly we'll be rolling into the final go, no-go poll for launch. Each flight controller that you can see on your screen there will be asked about their launch readiness by the launch director before we proceed to liftoff. Our launch director has about a dozen go, no-go reports in the poll, and at the end of the poll, the launch director will confirm whether or not we are go for liftoff. Let's bring up the mission control nets now to listen in.
This is the LD on mission, proceeding with the go, no-go sequence stage.
Stage is go.
Avionics.
Avionics is go.
GNC.
GNC is go.
VCON.
VCON is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
MM is go.
SVMD.
SVMD go.
LD sub.
LD sub is go.
That concludes the go, no-go sequence. We are T-minus 11 minutes, 22 seconds and counting. We are go for terminal count at T-minus 10 minutes. From this time, the 3-word hold procedure is in effect.
So as you heard, at the conclusion of the go, no-go poll, we are moving forward with the launch of the NROL-199 mission in just over 10 minutes' time. Liftoff has been set for right at the top of the launch window today, but if we need to scrub for any reason, we have a 2-hour block to try again and recycle the count as we need. Otherwise, launch is possible again tomorrow if we need to. Today's mission is our second of 2 back-to-back launches for the NRO from Launch Complex 1. Around 3 weeks ago, on July 13th, we launched the NROL-162 mission from Pad A, achieving a flawless launch and payload deployment to deliver the satellite to orbit. Now, NROL-162 and 199 are the third and fourth missions awarded to us by the NRO under their rapid acquisition of a small rocket contract known as RASR. This approach allows the NRO to pursue the use of both large and small satellites to create a space architecture to provide global coverage to help answer a wide range of intelligence questions. The first 2 NRO missions to fly under RASR also launched on Electron in 2020 in a showcase of the NRO's capability to deploy missions from spaceports outside of the United States. It's great to be supporting the NRO once again with launches on Electron, this time from 2 separate pads at Launch Complex 1. NROL-199 will be our third launch from Pad B at LC-1 in just over 5 months from when it was officially opened in late February. In fact, in just over the past 5 weeks, we have launched 3 missions from LC-1. The first was the capstone mission to the moon from tonight's launch pad, Pad B, followed only 15 days later by NROL-162 from Pad A, and now NROL-199 from Pad B for tonight's launch. Having 2 launch pads, range assets, and mission integration facilities for our own exclusive use within the same spaceport makes back-to-back missions like our 2 NRO RASR launches possible. To start with, we can run concurrent campaigns at LC-1 thanks to numerous clean rooms and plenty of room in the integration hangar for multiple rockets. 2 launch pads equal double the opportunity when we don't have to wait for a single pad to be refurbished between launches. And if customers' missions need extra time and attention, we can keep the rest of Electron's manifest on schedule by proceeding with the next launch. So even with just 1 pad at Launch Complex 1, Electron became the second most frequently flown US rocket annually. And with 2 pads at LC-1 and our 3rd in Virginia expected to come online by the end of the year, we are excited to see what Electron can do with 3 pads across 2 continents for faster and reliable access to space. Today's launch will be our 29th Electron launch, but in the not-too-distant future, we will be taking to the skies with a different rocket, one that's more than twice as tall as Electron, more than 3 times its diameter, and capable of lifting more than 40 times the payload mass that Electron can lift. That's right, we are deep into the development of our large Neutron rocket. Designed for larger payloads, constellation deployment, and even human spaceflight, Neutron is tailored to meet the ever-evolving needs of our customers. Neutron is a new breed of launch vehicle with reliability, reusability, and cost reduction hard-baked into the design from day one. Building on our extensive experience in developing and flying Electron, Neutron incorporates our best innovations of the past, like carbon composite structures, and marries them with cutting-edge technology and designs of the future, like our Hungry Hippo fairing design. Recently, we broke ground in Virginia on the production complex for Neutron, and work continues there at pace. The 250,000 square foot production complex is being built on a 28-acre site near the NASA Wallops Flight Facility and Mid-Atlantic Regional Spaceport on Virginia's eastern shore. Neutron's first pad will also be located there, close to the Launch Complex 2 pad for Electron. Right now, the Neutron team is scaling up, so if you want to be part of the team building the rocket of the future, visit our website to view the open roles now. And while we're on the topic of Neutron, don't forget to tune into our Neutron development update on September 21st to hear more about our development progress there. You can register to join that live webcast via our website. But for now, back to the mission on the pad, NROL-199. Let's check back in with the Mission Control Center for the latest. Every launch, before we roll out to the pad and get ready for the mission and, of course, ignition and liftoff of Electron, each Rutherford engine goes through a rigorous test campaign. Each of these engines, and in fact each of their components, go through extensive quality assurance tests at our propulsion test facilities. Each pump and motor controller goes through a flight-like acceptance test on our test rigs before they are assembled to a Rutherford. And then each engine must first pass a bench test before moving through 2 hot fire tests at one of our engine test cells. Finally, once the engines are assembled into the 9-engine configuration we call the power pack, the entire first stage and its engines are tested. We call this a stack test, and this process is in fact repeated for stage 1, stage 2, and the Curie engine module on our kick stage. Running our engines at least 3 times before launch is one of the many ways we drive mission assurance with Electron. Here's what our Stage 1 full stack engine test looks like. There you go. That's what 216,000 newtons of thrust looks like. And those engines will be doing the majority of the heavy lifting as we approach T0 in just over 3 minutes from now. So on that, we are very close to the terminal count for tonight's NROL-199 launch. Let's hand it over to our launch director to take us through the final reports from mission control operators and lead us into the 10-second countdown to liftoff.
All expected flight computer ASGOs are green.
Confirmed ASGOs are green.
Beacon, lock auto sequence and confirm.
Confirmed locked.
All operators, this is the LD on mission. We are go for auto sequence. Start at T-minus 2 minutes. LD is go for launch.
AVBs on internal power. AFGS is green and enabled for flight. Vehicle is fully on internal power.
Box load complete. System in recirculation. Anti-cars ring disabled.
Stage 1, Stage 2, rest for flight.
High flow engine purge enabled. Deluge is activated.
T-minus 20 seconds and counting. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And we have liftoff.
Switching over.
Stage 1 proportional is nominal.
HVB discharge looks nominal.
Entered burnout detect mode.
There we go, T plus 50 seconds into the NROL-199 mission on its Antipodean Adventure. Electron's engines will soon power down slightly to prepare the rocket to pass through max Q, or the point of maximum aerodynamic pressure against Electron during launch.
Cleared max Q.
Stage 1 propulsion is nominal.
And Electron has passed through max Q, the rocket's first major test after leaving the pad at Launch Complex 1 on the coast. You see below there on your screen. Electron's 9 Rutherford engines are firing hot as they burn through the first stage's tanks of liquid oxygen and RP1 propellant. T plus 1 minute and 42 seconds, and Electron's trajectory is also looking good. The rocket is at now over 30 kilometers above Earth and moving quickly at nearly 4,000 kilometers an hour.
Seconds to Miko.
Miko confirmed.
There you heard it and saw it on your screen, all three events happening back to back through Miko, stage separation and second stage engine start. Currently on your screen is Electron's second stage, continuing nominally for the NROL-199 mission. Soon it will shed its payload protective fairing to lose the unnecessary weight now that the vehicle is in space. In fact, there it goes, we can see it falling away on our screen there, so the payload fairing has split in half and fallen away. The NROL-199 payload is now exposed to space in preparation for payload deployment, and Electron's second stage is continuing to orbit, carrying the kick stage and the payload. Everything continues to look nominal, with the Rutherford engine glowing bright as it powers the mission on. The burn of this engine lasts for about 7 minutes to help bring the payload closer to its final orbit before we have a second stage separation that enables our third stage, known as the kick stage, to carry on with the rest of the mission. Our kick stage is critical in delivering the NRO the exact orbital insertion they need for this national security payload. With its own reliable Curie engine, our kick stage can be maneuvered precisely to achieve pinpoint orbital drop-off of the NRO's payload. That payload deployment is expected to take place around an hour from now.
Stage 2 propulsion still nominal.
Look at that beautiful view from space. Everything is looking great so far on this Antipodean adventure. Coming up to T plus 5 minutes and 9 seconds, and Electron's stage 2 engine continues to fire nominally along our expected trajectory, ready to deliver the NRO payload to space. We are about 1 minute away now from our next mission milestone, the swap of our rocket's batteries, providing electric power to the Stage 2 Rutherford engine you can see on your screen. So the Rutherford's electric fuel pumps use electricity rather than a pre-burner to operate. But once the batteries are drained, we don't need them anymore. They become unnecessary weight on the second stage, so they're discarded when we swap to a fresh new one that keeps the engine running. This is our battery hot swap event, which you can see about 3/4 of the way up the timeline on the left of your screen, and coming up shortly on the main screen, you should see that shiny silver object pop free.
Throttling down.
Approaching hot swap.
There you go, right on time. We have had battery hot swap on the second stage, confirmed across the nets and visually if you saw them falling away from the rocket on your screen there. We have had a clean run through mission milestones so far. It was only 7 or so minutes ago that Electron cleared the pad at LC-1, having since completed successful passes through max Q, main engine cutoff, and stage separation to reach this point now in the mission. Next up will be the second stage engine shutdown and the final stage separation that will follow the same process as the earlier MECO and separation of these stages, the first and second stages. So right now though, with Stage 2's engine still firing, the mission remains on its trajectory to orbit as expected, and all is going well for NROL-199.
FTS is saved.
We are well past the Kármán line now, travelling to this mission's destination in low Earth orbit. When we reach the end of this second stage burn and separate the kick stage, we'll drift along in an elliptical path around Earth before the kick stage's engine lights up and propels the mission into a circular orbit. That happens just moments before payload deployment and the end of the mission for Rocket Lab. From the ground to space and on-orbit operations within only an hour is pretty cool. Okay, so in the next minute or so, we should reach the final acts of the second stage for this mission, the shutdown of its Rutherford engine, called SECO, before the kick stage separates and carries on with the payload. We'll see the engine's nozzle fade from bright red as it cools down, and from there we'll be ending the broadcast as the mission continues to its classified orbit.
SECO confirmed.
Stage 3 separation.
Perfect transfer orbit.
There we go, that engine nozzle cooling off was the visual indicator, along with the confirmation from Mission Control that the second stage engine has shut down and the kick stage with the NRO payload has separated. There are still a couple of events to go on the third stage before payload deployment for the NRO. Our third stage will first complete that initial pass of Earth before it ignites to circularize its orbit and bring the payload to its drop-off point in space. That action will mark the end of the mission for Rocket Lab, but the start of the spacecraft's operation in space for the NRO, and we'll update you on payload deployment across our social media channels once it's confirmed. It has been a busy few weeks at Rocket Lab with the launch of the capstone mission to the moon only 5 weeks ago, on-orbit operations for that mission for the week following, and another mission for the NRO soon after that. Between capstone and NROL-162 was our shortest turnaround yet at only 15 days, with only 22 days to get us to today's mission. Keep an eye on Rocket Lab's social media for confirmation again of that payload deployment and mission success for NROL-199. But from the whole team, a big thank you to the NRO for entrusting us with the back-to-back missions for both 162 and 199. And thanks to you at home for joining us on our 29th Electron launch. We'll see you back here soon. This is Rocket Lab Mission Control signing off.